Section 2.2 is called the Algebra of Functions, and generally it's a relatively easy section because it's pretty straightforward. In this section we're adding, subtracting, multiplying, and dividing functions, and each operation does exactly what you think it would do. As an example, suppose we have f equaling x plus 1 and g of x equaling x squared plus x, and we want to find f plus g at 1. What we're going to do is we're going to take the function f and plug in 1 for the x, and then we're going to take the function g and plug in 1 for the x. And you might notice at this point that I go a little bit overboard on the parentheses, and that just sometimes makes it easier, especially when we're dealing with multiple functions and negative numbers, to keep things straight. But here we have our f of x with 1 in place of x, and here we have our g of x with the 1 in place of x. And then I just solve. So f plus g at 1 is 4. Now let's try f minus g at 2. We do exactly the same thing. I take f of x and I plug 2 in for the 1, and I'm subtracting g of x and I plug 2 in for the x. And then I just work it out. So f minus g at 2 is negative 3. So let's continue on with the same equations, and let's now do multiplication and division. So first let's do f times g at 2, and same procedure as before. I start with f of x and I plug in 2 for the x, and then I have g of x and I plug in 2 for the x. And now that I have all my numbers plugged in, I just work it out. So f times g of 2 is 18. Now let's try g divided by f of negative 1. Same basic idea. I take my g, plug 1 in place of x, and then I take my f and plug 1 in, negative 1 in place of x. And when I work this out, I get 0 over 0. And we have a problem down here. Because we have a 0 in the denominator, that makes this undefined. And you'll occasionally run into this with this type of problem. Just remember, 0 in the denominator means the answer is undefined. And now let's move on to the same type of problems, the addition, subtraction, multiplication, and division of functions, but let's do it in general and also find the domain. So on this first one, I have an f of x of x minus 6 and the g of x of x plus 3. And I want to find f plus g of x and the domain. Well, the first part's easy. I'm just going to take f of x, add it to g of x, and then simplify. So f plus g at x is x minus 6 plus the square root of x plus 3. Now for the domain, all I have to do is look at this final equation that I get out. And the only part that's going to cause problems there is the x plus 3. So I can't have anything in here that will make this radical negative. And if you forgot how to do that, we're just taking whatever's under the radical, setting it greater than or equal to 0, and solving for x. And then writing that in interval notation. So the domain on f plus g of x is -3 to infinity, and I'm including the -3, and I indicate that with a square bracket. Let's try the same thing for f minus g at x. We start out the same way. Have my f of x, and I'm subtracting the g of x. And then I simplify. So there's the answer to my question. And for the domain, I do the same thing. I'm looking for what is going to cause a problem with this. It's exactly the same as we found before, -3 to infinity. Okay, now let's finish up this problem set with f times g of x and f divided by g of x. Okay, f times g of x starts out the same way. Except now I'm actually multiplying the x minus 6 times the radical x plus 3. So I'm going to distribute the x over the radical x plus 3 and the minus 6 over the radical x plus 3. And there's my solution. The domain, exactly the same as before. The only thing that's going to cause a problem in the domain are these two radicals. And the answer is going to be just like it was before, -3 to infinity. And let's finish up with f over g of x. I put the f on top, and the g of x on the bottom. Nothing will simplify. So that's the final answer for f over g of x. The domain, though, is going to get a little bit tricky in this one, because this is the domain of radical x plus 3, but if I put that -3 in here, I'm going to get a 0 in the denominator, which is fine for the radical, but it's not fine for the fraction. So somehow I have to exclude the -3 from this domain. And I'm going to do that by just converting that square bracket into an open bracket. Now let's try a few of the more difficult ones. Here I have f of x equaling x plus 5, and I want to find f of x plus h minus f of x over h. So what I'm going to do is first take f of x and plug x plus h in for x. Then I'm going to subtract f of x. And this is one situation where parentheses come in handy. So there's my f of x plus h, my f of x, and the h. So let's just see if I can simplify this, and I can't. Here I have to distribute that negative over the x and the 5. And I just carry down that divided by h. Now on this type of problem, you're going to know whether you've done it right or not on this step. And you'll know you've done it right when you go to simplify the numerator and everything without an h in it goes away. So I end up with h over h which is just 1. Let's try a slightly harder one now. Here, f of x is x squared plus 5, and I want to find the same difference quotient. So first, I plug in x plus h into f of x, subtract f of x, and put it all over h. So just like before, I have f of x plus h here, subtracting f of x, and it's all over h. Now what I do is expand this out. And if you're wondering where I got that, I just FOILed out x plus h. So this is x plus h times x plus h. Now I'm going to distribute this minus over these two terms. It's all over h. And now I'm going to simplify. So the x squareds cancel out, the 5s cancel out. So I'm left with 2xh plus h squared over h. And again, you know you've done it right when every term without an h in it cancels out. Now I need to simplify this some more, so I'm going to divide an h out of the numerator. And that will let me cancel these two h's, which just leaves me with 2x plus h. And here's the final problem we're going to do. F of x equals 9 over x plus 3. G of x equals 1 over 7 minus x, and I want to find f plus g of x. So I'm just going to take f of x and add it to g of x. Now I want to add these two together, but I don't have a common denominator. And when you run into this situation, oftentimes the easiest thing to do is multiply the first equation by 1 in the form of the denominator of the second equation. So all I'm doing is multiplying this equation by 7 minus x over 7 minus x. And I'm going to do the same with this one. I'm going to multiply it by x plus 3 over x plus 3. And what that does is gives me the exact same denominator in each term. Alright, so now each term has the denominator 7 minus x times x plus 3. So what I'm going to do now is distribute this 9 over the 7 and the x. Keep the denominator the same. There's really nothing to do here. And now since I have the same denominators, I can just add straight across the top. So I'm just going to combine like terms. So negative 9x and positive 1x gives me negative 8x. 63 plus 3 gives me 66. And I just keep the 7 minus x and the x plus 3.